Hello, if you've got the Math 3 EOC coming up in North Carolina and you're looking for some Desmos strategies to help you on that exam, then you've come to the right place because that's going to be the focus of this video. For this video, I'm going to use the released items that are available publicly through the state of North Carolina. If you Google NC Test, it'll be like the second link that comes up, it takes you to this web address, and you can log into the released items. So this would be a helpful video if you are taking the Math 3 EOC online, which most schools do now that I'm aware of. I'm going to skip through the sample items because there's no calculators for those, and the focus of this video is Desmos strategies. There are other videos out there that focus on algebraic strategies. I encourage you to check those out as well, because certain problems like this one, number 1, can really only be done with an algebraic strategy. In this case, you'd use synthetic division. So question number 2 from the sample items has a polynomial f of x, and it says, what is the total number of real zeros? Now I know real zeros are x-intercepts on a graph, so I'm going to use Desmos to find how many there are. The other information that's given could be helpful if I was using an algebraic strategy, but that's not the focus of my video. So first handy tip is when you're taking the EOC, you need to expand the calculator window if you want it to look like what you're used to when you use Desmos online. Now I need to type this function f of x, and now it says what is the total number of real zeros. So there's 1, 2, 3 real zeros. It doesn't ask me what they are, just how many there are, and that's 3, which incidentally would mean there's 2 complex roots as well, or 2 complex zeros, because this is a 5th degree polynomial and it has to have 5 total. So if you're watching this video, I encourage you to try these problems as I go along. So open up the NC Test platform, pause this video, and try that problem to see if you can replicate my process. Because just watching the video and not practicing the skills and practicing using Desmos is not going to be as helpful. It'd be like watching Steph Curry shoot free throws and then not practicing free throws on your own. It's probably not going to help you get better. So you've got to practice these strategies. Next question, number 3, function m of x. And it asks for zeros of that function. So again, I can use Desmos. This time I'll make it even bigger. And you don't even have to type the m of x, but I like to just do that, stay consistent. So I see it has these 2 decimal zeros and the 0 at -1, just like I was promised. Automatically option A and B are eliminated because they don't have, those are not shown on the graph. So it's between option C and D. How do I get something that's not a decimal to become a decimal? Well, I can type it into Desmos. -1 plus the square root of 5 is that, and -1 minus the square root of 5 is that. Those look familiar because those were the values of the zeros on the graph. So I have determined that it is option C. This is another type of problem you can do. The last 2 was a key vocabulary term of zeros. Anytime you see this phrase equivalent, which expression is equivalent to this one? That means I can graph the listed expression and then graph each answer option and see which matches. So the listed expression, I can use this division symbol here, which creates a fraction. So I just type the first expression on top, second expression on the bottom, and that means the same thing as what I've highlighted there. Now I want to type each answer option until I get a match. So I have x plus 3 over x squared minus 3x minus 40. And look at that. The blue graph lands perfectly on top of the red graph in every place. So that would mean that this option A is correct. Just to show you what it would look like if it was not the correct answer, option B, for example, the blue and red graph do not perfectly align in every place. It was option A that did that. This is a type of problem that you can do using Desmos, but it's going to take just as long as if you did it algebraically. And I would argue that if you know the algebraic strategy, it's easier to do this one that way. But I'll show you the Desmos strategy because that's the focus of this video. First, anytime I have an equation, I need to type the left side of the equation, whoops, that's not what I wanted plus, and the right side of the equation in separate rows. So say that again. Anytime you're dealing with an equation and trying to graph it in Desmos, you have to graph the left side, as I just did, and the right side on separate rows. And this is a lot for me to type. Thanks for hanging in there with me. Boom, there we go. So now, because I have these other variables, or other constants, I should say, a, b, and c, in addition to x, Desmos is going to ask me to add sliders. And I want to do that. So we're going to use a trial and error approach here. It's going to be way faster using Desmos than if I was trying to plug in values. So let's just say I start with an a of 12, a b of negative 31, and a c of negative 7, using the first options across the top. I can see that that's close, but it's not quite a match. So I'm going to try a b of negative 33. Maybe I change my c to negative 3. Maybe I try 13. I'm really close now. So I go back to this b, and maybe I try negative 43. And it looks like that's a match. But if I zoom in, I can see it's not quite perfectly aligned. So I need to try an a of 13, and now it's a perfect match. So for this problem, I would slide in a of 13, b of negative 43, and c of 13. Now, if anyone tells you that these strategies using Desmos are cheating or anything like that, that's not accurate. It's simply using the tools that are available to you. In my opinion, it requires a different type of intelligence to be able to use Desmos. It's like a computer programming type intelligence, which is respectable in its own right, just like algebraic strategies are respectable. My goal here is to just give you all the tools so that you can do the best you can on your EOC. This one's going to be really hard to do using Desmos, but I'll show you anyways. The reason it's challenging is because I have a fraction that I need to start with. So x squared minus 5x plus 6 raised to the negative 1 power. Whoops, need that negative 1 to be outside the parentheses. And then I have x minus 2 raised to the negative 2 power. So when I do this division symbol, it's going to put another fraction, so I need to put the entire second expression in the bottom of that fraction. So this is a lot of computer programming skills here to make sure that I graph things the right way in Desmos. And that's what I mean. It requires intelligence, just a different type of intelligence than algebraic strategies. And now I've graphed it correctly. What I've graphed is equivalent to what was given. And now again, remember, anytime it says which expression is equivalent, our strategy is to graph the original expression and then graph each answer option. So I graph option A, and that is not a winner because the blue and red graph do not match. I notice that option B is the same as option A, just change the minuses to pluses, so that's not a match either. And now I'm on to option C, which is close but not quite a match, and finally option D is a perfect match. The blue graph is right on top of the red graph in every way. This problem, not really going to be too helpful to use Desmos. Trust me, algebraic strategies, there's other videos for that. This one, easiest type of problem you can do using Desmos. It shows us a graph and asks us which equation matches that graph. So I simply need to graph each option and see. So I have y equals the absolute value of x minus 2 is the first option, which looks promising at first, but then if I dig a little deeper, I see it has the wrong zeros. I need negative 1 and 1. So option B is the same thing, but it's 2x minus 2, and now that's a perfect match with the graph. And you can see it better if I click the house button and zoom in. So option B is the winner here. This one again, Desmos, not going to help us. All right, here's one where we can definitely use Desmos. We have two functions, f of x and g of x, and it says what is the y value when f of x equals g of x? So I can graph f of x Remember, anytime there's an equation, I want to graph the left side, which in this case is f of x, and the right side, which in this case is g of x, and find the intersection. This time it says what is the y value when those two things are equal. So at this intersection point, the y value is negative 1.75. All right, this is one where it says which choice is equivalent to the expression shown below. I've said we can always graph the original expression and then graph each answer option for those types of problems. So let's check it out. In this case, something happens, there's an error, and that's because Desmos can't graph an expression like this that has both x and y. So what if I let y equal 1? Well, 1 squared would be 1, so I could just type that. I can't promise that this strategy would work in every case, but it will work for this problem. We just let y be 1 and see what happens. So now the a expression when y is equal to 1, it becomes that. That's not a match. The b expression would be that, which is also not a match. The c expression, both of these are minus again. Once again, that's not a match. And our expression d is also not a match. So that means I messed up somewhere. So let's go back through the options. So there was D, then C, oh, I see those. So D does not have the squareds on the axis. Neither did C. But there we go. We can see D is a perfect match. And again, sometimes you got to be a little patient with your Desmos strategies. Make sure you're avoiding typos. All right, this one requires a little understanding of some vocabulary. Polynomial p of x has a lead coefficient of 1 and 3 distinct zeros. X equals negative 1 has a multiplicity of 2. So a multiplicity of 2 is a touch and turn on the graph, which I'll show you as we graph the possibilities. So I'm looking for one that has those zeros and it has a touch and turn at negative 1. So if I graph option A, it has the right zeros, but there's no touch and turns. There's all these cross the x-axis in a normal way. A multiplicity of 2, it will bounce off the x-axis or have a touch and turn. So I'm going to try option B, which just changes this to a plus and this to a minus. Those are not even the right zeros. So now I'm on to option C. So I need to make this a little bit smaller so I can see it. There we go. We have x to the 4th minus 4x cubed minus 3x squared plus 10x plus 8. Now that is a multiplicity of 2. That's the touch and turn that I was talking about. And those zeros are the correct zeros that were listed in the problem. So we know that this one is option C. All right, here's another one where we can use a slider. And this might be the last one that I have time for in this video, so I'll have to make another video. If this has been helpful to you, be sure and like and subscribe so that I can know that there are people out there interested in more videos like this. So I graph the function f of x. I can add this slider, and it says, what is the effect on the graph as k increases? So I look at the graph now. As k gets bigger, I notice that the graph is stretching vertically. Imagine holding your arms up and then stretching them up vertically. As you stretch, they're getting closer and closer together, just like this graph. So that is a vertical stretch. Cool. Next video, we'll start with this problem. Thanks for watching. I have a 15-minute time limit on my account here. So I'm going to stop there, and I'll pick up the next video with problem 14. Desmos strategies for the Math 3 EOC. Thank you.